Welcome to the Boolean Brain. In continuation to the LeetCode Daily Challenge, where we are trying to solve the daily challenge from LeetCode end to end. Let us take a look at today's problem statement. Okay, problem title says Maximal Rectangle. Given a rows and columns binary matrix filled with zeros and ones, we have to find the largest rectangle containing only zeros, only ones, and return its area. Okay, so we have given this 2D binary matrix where we have to find the area of the largest rectangle. As you can see, in this case, the possible rectangles are this, the first column, which contains of size 4. Similarly, there is another one here which contains of size 5, but the maximum is this one, which is of size 2 by 3. So we have to return the 6. Okay, now, okay, the difficulty of this problem statement is hard. Now let me help you understand how should we approach to such problem statements. So whenever we come across such hard problem statements, it is not directly straightforward. There is some hidden inner sub-problems that are hidden inside a given question. Our goal should be to find out what is the pattern inside it. So we have given this 2D matrix and each value contains either 0 or 1. Okay, and we have to find the largest rectangle, right? So in order to find the largest rectangle, you have to basically change the perspective of looking at this problem statement. For example, when you are at imagine this as the given 2D matrix as a histogram. How? Let me show you. If you carefully observe the first row, let's say this is my given uh, row, and this row basically represents a histogram. The first one is contents of size 1 and similarly third one contains of size 1, the rest are 0. So if this is the problem statement, what is the maximum area that I need to find? Can I find? Yes. Similarly, if there is next row, now when we are at second row, imagine you just visualize these two top rows. So the histogram, the bar size at index 0 would become 2. Again, it is 0. At column 2, it is 2. Column 3, it is 1. Column 4, it is 1. Now, if this is my given histogram and each cell represents the bar size, can I find the rectangle, maximum area rectangle? Maybe yes. How? I don't know yet. Let's see it further. Similarly, for each of the for each row, let us try to build this. For this, we have 3. Now, if I am at this position, what is the bar size? 1. If I am at here, bar size is 3. Again here it's 2. Again here it's 2. Okay. Now, again I don't know what's the size. Now we are at row 0, 1, 2, 3, third row. At the last here, what is the maximum size of the bar above it? It's 4. And here it's from here it's 0. From here again it's 0. From here it should be 3. We only need to take and consider the continuous. For example, from here the continuous we do not have any, but if we leave this, 3 are present. So we have to consider such scenarios. From here again it's 0. Now if I were to solve this individual row problem, if I'm at this position, okay. So basically, the largest rectangle would be the one when I am trying all possible rectangles, right? And how can I try all possible rectangles? By treating each row as an individual um, histogram and finding the area from that histogram. That's how we will be able to find it. Now, the problem statement of this maximal rectangle has been reduced. So this reduced to basically finding largest rectangle in a histogram. Now, if you're aware, this is a common and popular standard question, sub question. Again, this itself is a hard category question. So, in order to find this, again, since we want to go on each level, we want to have this in linear time. So, how can we find the largest rectangle in a histogram? So, in order to do that, you might have the intuition of thinking to solve this problem should be like, I need, I'm given the bar size at each location. If I'm iterating on the bar sizes of this histogram, what data structure would I need to keep a track of previous such that I need previous smaller and I need the next smaller. So to find out the area of the rectangle forming in between. Because if you carefully observe here, if just observe these three, if I am at this bar, the height of this bar is 1, the next smaller is the next smaller of 1 is not present. Next smaller of 3 is not present. It means it can form a size of rectangle of entire row. Okay, but similarly, when you are at this position, when you are at this position, in order to find the maximum rectangle containing this size is I need to find the next smaller. Next smaller is 2. Can I form a rectangle of height 3? No, I cannot. So my height 3 stops here. Similarly, on the left, the previous small, I am at this position where this is the smallest, so I cannot go even further. So maximum rectangle that is forming is this only. So if you carefully understand this logic, you need to find next smaller element and previous smaller element for we have to find the next smaller element and previous smaller element, okay, in the given histogram. And this is again, these are smaller individual sub problems that you might find by searching on the internet. Now, in order to find this, we need some data structure I mentioned to keep a track of these elements. We can do that using tag. So, okay, now this is how we have to try to break a hard problem statement into the smaller sub problems. So, explaining the entire solution right from this to this is not possible in one video. So, I would suggest to try to go from this. First, try to find out NSE and PSE, the next smaller element and the previous smaller element. Then try to solve this problem. Then this approach you will easily understand. For now, let us, by assuming these elements are aware and the logic that I would be presenting is kind of a black box to you. If you are not aware of this might sound a little difficult, but I'm sure if you are aware of this, you will understand clearly. Now, my first step was to calculate this matrix. And another thing is I have given us characters I need to convert to integer. So let me initially declare a integer matrix. Okay. So let me fetch the size first int and equals to matrix dot. Okay. So this is m and this is the size. I need to declare of size m rows where each row is of n columns initially assigned to 0. Okay. Now I need to populate this matrix. So in order to do that, if you carefully observe, I need to operate column wise. Instead of regular row wise, I need to operate on column wise. So let me take two loops. One, I starting equals to 0, I less than n I plus plus. Okay, so I'm iterating for the column wise. Now the inner loop j equals to 0, j less than n, j plus plus. So this loop would be for row wise. Now I need to check if matrix of I of j exactly equals to the character 1. If it is of character 1, let me take a count in once total count once count assigned to 0. I simply need to increment the count, else my count becomes 0, and at the end of this condition I have to populate this integer matrix of j column and ith row, sorry, jth row and ith column with ones count. Okay, now once the entire inner loop is complete, we will move on to the next column. Likewise, the int matrix would be formed. Now we need to find the largest rectangle for each of the row. Okay, largest rectangle. Let me define one function. Okay, so I will call this for each of the row. If I equals to 0, I less than n, I plus plus. If I also need to declare one answer for returning, initially assigned to 0, and I declare return it at the end, my answer becomes maximum of answer comma answer comma. I need to call this function for each row, largest rectangle of int matrix. Okay, now let us try to complete this function. This takes input of integer matrix, so let us accept this here. Let's accept by reference. Now I am at now the problem statement has been reduced. As I explained you, I only need to solve about this largest rectangle for given histogram. Sorry, my bad, one mistake. Instead of passing the entire matrix, I need to pass each row. So I represent the ith row. So the input changes here to vector of int and set heights. Okay. So since we are calling it as a histogram, each element represents the height of the bar. Okay. Now, as you can see, for each, in order to find the largest histogram, for each position, we have to find the next smaller and the previous smaller. Okay. And we are using the data structure used is stack. Let me declare a stack first. Now, what I need to do, initially my stack is empty. Okay. Let's try to complete this function with this example. My histogram heights given is considered, let's say, this. Now I am at the first position. when I'm at the first position, can I find the previous? Yes, the previous I know. Can I find the next smaller? I do not. So I cannot compute the next smaller unless I visit to that position. So the current element I will not get processed until and unless that element we visit to the smaller element associated, next smaller element associated to the current. Okay, so we need to traverse till the end. Let me take the loop initially assigned to 0, I less than its dot size I plus plus, and for each element I need to check. Sorry, and yeah. Now for this ith element, I'm at this position, right? I need to check what is in my stack at the topmost element. So I'll check if so since I do not know the further elements, I need I need NSE and PSE, next smaller and previous smaller. Do I know the next smaller? I do not. Do I know the previous? I may. So in this stack, this will store the previous smaller element. Okay, cool. Now when uh, now how to do that is if I need to keep popping on the elements. So we are storing the index here, right? So we have to access it. Heights of top is greater than the heights of I because we need the previous smaller. So whatever large elements which are present at the top, I need to pop it out. And for each popped out element, for each popped out element, I can find NSC and PSC. So if I am let's say I am popping out one. Let's say I'm popping out one. What is the next smaller element? I'm popping out one when I'm at zero. Because in order to find the less element greater than zero, I need to go backwards and this popped up, this condition satisfied, top is greater than heights of element, this. So next element, next smaller element for this element is nothing but the ith element. I'll simply update to I. Similarly, for updating the previous smaller element is nothing but the other element at the stack, the before element of the current top. Yes, it is. So I'll update this here. But there are some base conditions. The conditions are we are accessing the top, right? So stack should not be empty. So this is the condition. In order to access the stack, if the stack is not empty, otherwise let's do this likewise. If the stack is empty, if the stack is not empty, I'll access the stack dot top, else -1 because the index is finished and the other is -1. Okay. Now, what is the area? Let me declare one answer here to for returning. If answer equals to 0, I will return this at the end. And answer equals to what should be the answer here? max of answer, comma. So NSA and basically PSC gives me the width, and the current element is nothing but the height. So height of element multiplied by NSC minus PSC minus 1. So this gives me the width, this is gives me the height, and I'll update the answer based on the value that I'm getting. Okay, so that's how all the elements. Okay, and after the end, after processing this, I need to push back the current element in the queue in the stack, isn't it? So if you dry run this quickly, for the first element, this is the stack is not empty. The stack empty gives true, true becomes false. Our element gets added into the stack. Now one present in the stack. Now when we come to zero, we check if it's empty, it's not empty. It's the top element, one is the top element. So value of one is one greater than heights. Yes, it is. It means for one we received a smaller element to the right. So that's how next smaller is I, and the previous element is nothing but I simply check the top element out of again. But in this case, I do not have the top element when I remove one. So I'll simply take minus one. Means this index, the my previous to zero. That's how I'll get all the answers. Now, this way, we will operate on all the elements present in the stack. But at the end, there might be still some elements which are yet to be processed. So what we will do, we will add another while loop till the stack is not empty. For each element popped from the stack. Now the next element is nothing but end. And what is the end? End heights dot size, isn't it? What is the my previous? Yeah, the same condition should remain as it is. Answer value method is also same. Let us try to run this. Okay, let's try to run this and check. Okay, there are some errors. Yeah, it should be heights. It should be heights. Okay. Mm, heights of element is given index of this heights into. Okay, I am redeclaring it here. It should be just update. Okay, okay. This is not vector of it's a plane now, right? It's a single my bad. It's a 1D array. Okay. Errors. Let us whenever there are errors, there is the loop for learning. Let us try to understand this. We declare a size mn0. Again, I'm doing this all with you because you should also know how to debug. Okay. Now, I declared a 2D matrix of size int because existing was character, and I declared it m by n assigned 0. I'm processing column wise and fetching, keeping the track of ones in each track. Now, for j less than n for the rows, if matrix of, okay, it should be g of I because I'm moving column wise. Okay, this is one mistake. Let us try to check. Okay, at least we got some answer. Now, let's keep debugging further. Now, once count is updated, if it is 0, I update to 0, and here Again, I update. Yeah, it's correct. In matrix of J of I is ones count. Now my answer is initially assigned to 0. I'm starting a row-wise loop and is for rows. Cool. And updating the answer with the current answer or the largest rectangle. Largest rectangle is nothing but I I returning the answer. Okay. Now let me add a simple log. The length of video might increase, but this is useful debugging, which is essential. Okay, 10100. Is it the same as what we expected? 10100. Okay. Now it means at least at this point we are good. Let us try to debug this. Here we are iterating starting from, okay, this was the logs. We can comment this. We declare a stack, we declare answer assigned to 0. We are starting a loop from the 0th to heights.size. We are checking if heights of the current top element, heights of current top element is greater than heights of I. Let's say I'm at 0th position. I want the previous smaller, but the top element, if it is greater than the current, at that point I need to I can process the current element and I can pop that. Yes, at that point my next smaller for current element, my next smaller is the ith position. That is good. My previous smaller element is, I need to check if it is making sense. If the stack.empty, if the stack.empty, if it is not empty, I will simply return the top element. Otherwise, I return the -1. Now, while calculating the answer, equals to answer, comma, heights of element. Okay, yeah, that is right. We are accessing heights of element. And next smaller element minus previous smaller element -1, and I'm pushing the current element into the stack. Okay, I need to, for this while it is operating on, till end of some elements exists and current element is top. I pop the element. My next smaller element is heights.size. That is correct. My previous smaller element, again I checked. If it is not empty, stack.empty gave me, let's say it returned true. So there are no elements. There are no elements. Return -1. If there are elements, I return the top. Now My answer is answer, comma, heights of element into NSE into NSE minus PSE minus 1. Again, oh my bad. I think I'm redeclaring it here. Sorry. So this is the mistake that we should avoid while coding or in an interview. Yeah, all the test cases are passing. Let us try to submit this. Yes, we have successfully completed the problem. Now let us try to understand the time and the space complexity. I think I submitted it again. My bad. So in order to find the time and space complexity, this is loop running for the columns and this is row m into n. Okay, so it's definitely O of m into n. What else? Here we are operating on each row. So m into largest rectangle plus m into the largest rectangle. In what are we doing in the largest rectangle? In largest rectangle, we are having the loop till the size, and for each we are checking the um, uh, what are the elements at the top, right? So this happens at max in O of 1. So for this O of n only, so it is O of n. Overall, it is P O of m into n. Similarly, space complexity, we are using just one extra space of this uh, of storing. It's of m into n. Okay. I hope the logic approach and the idea to break down a large problem statement into smaller subproblems and solving the smaller subproblems in order to find the big solve the big problem is clear to you. If you have any doubts, please do let me know in the comments. And if you are watching till this point, please give it a like and subscribe to the channel. Thank you.